latest addition to the Boeing family of versatile jet transports. An airplane that's on target, on schedule. Rolled out in January 1982, it underwent an intensive test program leading to certification. The plane, the Boeing 757. A mere 5 weeks after its unveiling, the first 757 took to the air, quickly joined by 4 other sister ships amassing required data. An unusual test for the 757 was one to confirm that engine and instrument locations weren't affected by water spray from wet runways. The airplane was coated with a colored solution, which was washed away by spray, revealing the path of the water splashed by the wheels. Runs through water up to 1.5 inches deep did not affect the airplane. At Edwards Air Force Base in California, the 757 underwent refused takeoff tests, establishing the distance required to safely stop the airplane when accelerated to takeoff speed, and the run then aborted. The airplane was stopped using only the spoilers and maximum braking. Thrust reversers were intentionally not used during these tests. Under these extreme conditions, brake temperatures reached as high as 1900 degrees Fahrenheit. During the 15 tests, the tires and brakes were changed 6 times. Refused takeoff tests were conducted at gross weights ranging up to 240,000 pounds. Even at its heaviest, the airplane was safely stopped and then taxied off the runway. Meanwhile, in Seattle, Washington, another 757 flies hour after hour, yet never leaves the ground. An airframe, right from the production line, is subjected to all the fatigue loads that are repeated hundreds of thousands of times during its lifetime, an average of 50,000 flights. A minimum of 20 years. All the stresses and strains associated with a normal flight are applied to the 757. In a steel frame, actuators push, pull, and twist the airplane. About every 4 minutes, the earthbound 757 logs an hour of simulated flight, amassing the equivalent of not 1, but 2 lifetimes of service in a highly compressed time span. Another non-flying airplane provided valuable data confirming the structural integrity of the 757. An airplane must demonstrate that it can withstand 2.5 times the normal service loads without experiencing any permanent bending. This limit load must then be extended even 50% greater to ultimate load before damage occurs to meet certification requirements. To prove that the 757 could withstand these loads, a static test was conducted. Hydraulic rams deflected the wings upward, slowly bending them higher and higher until the limits were met. Once that was accomplished, Boeing went yet a step further. The pressure was increased, pushing the wings beyond the limits. At almost 113% of the goal, the wings finally broke. Confidence in the design provides the opportunity for higher gross weights of the airplane with few changes. Other performance tests established the slowest speeds at which the 757 would safely lift off the runway. With the tail protected by a wooden skid, the airplane was fully rotated until the fuselage dragged the ground. The position was held until the main gear lifted free and the 757 was flying. Steam trailed the airplane from the friction-heated skid. Onboard data processing equipment analyzed each run, conducted at various flap and thrust settings and at differing gross weights. Information on each test was available moments after its conclusion. While certainly not the normal takeoff, the 757 still handled safely, even when so abused. Landings of the 757, conducted at Great Falls, Montana and Casper, Wyoming, demonstrated the ease of control in crosswinds. Flying the airplane both manually and using the Autoland system, landings were made in direct crosswinds of up to 25 knots. Almost 1 million man-hours have gone into demonstrating the 757's performance and reliability, a winning combination of new design and new technology. It's an airplane with outstanding fuel efficiency, an airplane that's easy to maintain and costs less to operate. Setting new standards for decades to come. The 757 from Boeing.